Hello, I'm John Gabriel. And this is a new calculus channel once again. So, what I'd like to do now is just address very quickly a question or something that keeps coming up. So, there's a comment here saying you're correct because no matter the size of the circle, it's the same thing. Actually, that's true in the sense that the circle has the property. Okay, so any circle has the property that its ratio, that the measure of this diameter 1, rather the circumference 1, the measure of the circumference 1 with the diameter 1 is equal to the measure of the circumference 2 to the diameter 2. Okay. While the measure is the same, meaning it results in some approximate constant, which is 3.14159, right? Etc. While the measure is the same, the ratios are not the same. Okay, this ratio here, C1, D1, is not equal to C2, D2, right? They're totally different. They're not the same ratios. It's the same. So let me give you another example. Reset the canvas. You could say that, all right, you could say, let's say you have this, oh dear, I didn't mean to do that. Okay, that line. Let's take this line here, and let's say we have another two lines like that, right? So the measure of this ratio, the measure would be a half, right? Let's just say measure like that would be equal to a half, right? And if we had, using the same line segment, we did this. And again, these are all equal, right? These line segments. Then the measure of this ratio would also be a half. But these ratios here, this ratio and this ratio, are not equal, okay? They're not the same ratio. So they're in proportion, yes, very much so, because I mean, I can add, if I add this lens to this side, I know I have to add two of these to this side, right? Like this. And if I subtract one of them, I have to subtract two of these from this side. So I can easily form any number of ratios that are in proportion. Not equal, but in proportion. However, all of them in algebra have the same measure. Why? Because algebra doesn't care about the size of the abstract unit. Okay, it doesn't care about the size of the abstract unit. Whether it's that or a bigger size, algebra doesn't care. That's what it means when you talk about the abstract unit. Okay, it's the unit that enables you to generalize measure. And as a result of generalizing measure, you lose the precision you have in geometry, which is 100% precision. So you don't have that in algebra. Algebra is a weaker form of geometry. That's all I wanted to say. Goodbye.